All right, so if you're watching this video, so this question here where it says what is the interval of convergence for this series, it's a good one because it can be done one of two ways. The quickest way to do this problem is to notice it's a geometric. Okay, like how would you notice that? Well, you could do a little rewriting. Okay, so like you can write this like this. And then again, writing out the first few terms. When n is a 1, you get this. Okay, etc. Now it's obviously a geometric. It's a geometric where, this is our first term and our common ratio. So this is AR, right? Oops, this is A times R. So our common ratio is x minus 5 over 4. And so applying the geometric test, a test for a geometric series, we know that these converge, okay, when absolute value of r is less than 1, which in our case means this. Which means this, which means this. Okay, and again, adding 5 gives you, that. So that is the answer. And that was the quickest way to do it. So that was the quickest way. I'll call this way 1. The thing is, if you've done a whole bunch of ratio test problems, you might not be in this mode, which is fine. I just want to show you that the ratio test works too. It's just a little longer. So if you use the ratio test, okay, the ratio test says to examine this ratio and then take its limit as n goes to infinity and make it so that it's less than 1. And then you do have to check the endpoints. So in this case, you'd get, so this ends up being absolute value of x minus 5 to the n plus 1 divided by 4 to the n plus 1 times the reciprocal of the nth term and notice this cancellation leaves behind one of those, and this cancellation leaves behind just a 4 down here. So in the end you get and we want that to be less than 1. But now notice like we're in the exact same situation as we are over here, right? Okay, so that means everything from here on out is going to get us to here. Now look, when you're doing the ratio test, you should check the endpoints. So when so again, our series looks like this. The endpoints are never going to work for your geometric though, because they produce 1 and -1. So how do you know that? Well, that's what I'm showing you in this video, and you can explore that if you want. But so here's our series, and when x equals when x equals 1, this first endpoint, we get the series 1 minus 5. So you get -4 to the n over 4 to the n, which is, sorry, that was sloppy. You get, this is just -1 to the n, which diverges. Okay, that's a divergent series. And then when when x equals 9, notice what you'll get. Okay, you get this. Okay, which also diverges. So in a geometric, the endpoints never need to be checked if you notice it's a geometric, but you could always rediscover it. So those are two ways to do it. The geometric is quicker, but either way, this is our answer.